All right, guys, on Tuesday, you have a quiz. I have posted some quiz practice, quiz review. It's not due until Tuesday morning, but when I'm done with these notes, you guys are going to start working on it. And then tomorrow in class, I'm going to go over it and answer questions. I'm going to do a review video so you guys can review it over the weekend, but your quiz is going to be on Tuesday when you come in. So just make sure you guys are looking at this over the weekend. I did yesterday in class the first example. I'm going to do the second two examples, and I'm going to talk to you about some different things that you can look at, kind of give yourself just kind of some guidance on how to answer some of these questions. On your quiz, there is not going to be anything that asks for everything all at one time. It's just easier when we're doing notes and stuff to do everything at the same time with the one problem. But each question will be like, here, this one find the domain and vertical asymptotes. This one find the x and y intercepts, that sort of thing. You will not be able to use your cheat sheet. You have to know where to look for all of these things. So that's why it's important for you to have it next to you right now, but to understand that you have to do this on your own. If you are asked to find the zeros, give yourself a little quiz here. Zeros is the same as x-intercepts. You need to remember that we write x and y intercepts as what? Ordered pairs. Has to be in an ordered pair. If it's not, I'm taking points off. X and y intercepts are ordered pairs. So when you plug in 0 for x, you find y. When you plug in 0 for y, or when you set the numerator equal to 0, you find x. To find the zeros of the x-intercepts, you set the numerator equal to 0. To find the vertical asymptote also goes with what? Domain. All right? You're looking at the denominator. Your vertical asymptote is always x equals. It's not just a number, it's x equals. Your domain needs to be written in interval notation. All of these things have to be done in order for you to get full credit on stuff. Your horizontal asymptotes, that's always going to be a y equals thing. Your answer could be none, or it could be y equals 0. Those are two different things. Horizontal asymptotes is where you compare the numerator degree to the denominator degree. We'll talk some more about that in a minute. Wholes is when you factor the numerator and the denominator, and anything that they have in common, that is where the whole is. So you would set that common factor equal to 0 and tell me there's a whole or wholes at x equals whatever. Your y-intercept is where you plug in 0 for all the x's, and then you will write that as an ordered pair as well. This is already on your cheat sheet. We talked about all this yesterday, but I want to make sure you guys are on top of it. And then slant asymptote. Not every equation is going to have a slant asymptote, and that's okay. Your slant asymptote has to be written in y equals mx plus b. Y equals mx plus b. Do you include the remainder if you have a slant asymptote? No. You do not include the remainder. All right, so let's do these two examples, and then I'm going to give you some little tips that I want you to remember, and then I'm going to let you guys start. But the first thing I always find is the domain and the vertical asymptotes. Those go hand in hand. You find both things when you solve for this. So where do we look for vertical asymptotes?
The
Denominator. So I'm going to say x squared minus 9 equals 0. So if I solve this, x squared equals 9, I take the square root and I get x equals plus or minus 3. That means your vertical asymptote is at x equals, plus, you can write plus minus if you want to, or you can write x equals 3, x equals negative 3.
That's the domain as well.
That's the boundary for your domain. When you find what the vertical asymptotes are, those are those vertical lines that your function gets really close to but doesn't touch, you're also finding the domain. You're saying you can use every single number in the whole world except for, which two? Negative 3 and positive 3. So how would you write that? Negative infinity to negative 3. Union, negative 3 to 3. Then what? 3 to infinity. Perfect. So that's how we find vertical asymptotes and domain, by setting the denominator equal to 0. The next thing I always find is my horizontal asymptotes. So think about that. How do you find horizontal asymptotes? This is how you guys would show me your work. How do you find horizontal asymptotes? What does it say to do? Compare the numerator and the denominator degree. So I write an N and a D. What is the degree of the numerator? 2. It's the highest exponent. What's the degree of the denominator? 2. So you compare those. Are they greater than, equal to, or less than each other? They're equal to. So if the numerator degree and the denominator degree are the same, how do you find the horizontal asymptote? It's the leading coefficient of the numerator, which is what? 1 over the leading coefficient of the denominator, which is what? So your horizontal asymptote is at y equals 1. Your horizontal asymptote is always at y equals. You don't always have one, and that's okay. All right, next thing, let's find x and y intercepts. How do you find the x-intercept? Numerator equal to 0. You're going to factor, guys. X squared plus 5x plus 6 equals 0. What are the factors of positive 6 that multiply to give me 6 and add to give me 5? Bless you. X plus 3 and x plus 2. So you have 2 intercepts here at x equals negative 3 and x equals negative 2. How do I want those written? Ordered pairs. So how would you write that? Negative 3 comma 0 and negative 2 comma 0. Your x-intercept are ordered pairs. How do I find the y-intercept? You're going to plug in 0 for all of the x's. So I say, okay, 0 squared plus 5 times 0 plus 6 over 0 squared minus 9. This is how you guys will show me work. If you're going to simplify this, this cancels, so you have 6 over negative 9. What does that equal? Negative 2 over 3. That is an intercept, so how am I going to write it? I plugged in 0 for x, and I got out negative 2/3 for y. There's your y-intercept. Anybody have any questions so far? All right, so holes. How do we find holes? All right, factor numerator and denominator. We already factored the numerator. It was x plus 3, x plus 2. We've already factored the denominator, or we solved it, right? What's the denominator? X plus 3, x minus 3. Do you see a binomial that is exactly the same on the top and the bottom? The x plus 3. This is what you set equal to 0. That's where the hole is. So you would tell me x plus 3 equals 0. So there's a hole where? There's a hole at x equals negative 3. You have to be specific with the x's and the y's, guys. There's a hole at x equals negative 3. All right, what's the one thing we didn't find yet? Slant asymptote. Remind me how to find slant asymptote. Long division. So x squared minus 9 is going to go on the outside. I have to have a placeholder for x because there is not an x value. The inside is going to be x squared plus 5x plus 6, right? So remember, our y equals mx plus b. You have to have a number in front of x to have a slant asymptote. So if I'm going to work this out, I'm going to say, okay, fine. First term, first term into first term. How many times does x squared go into x squared? Once. So get your subtraction set up. 1 times x squared is x squared. 1 times nothing is nothing. And 1 times negative 9 is negative 9. So distribute, 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 distribute. And you're left with 5x plus 15. Okay, is there anything else to bring over? No. So 5x plus 15 is your remainder, so it doesn't mean anything. What this says right here is y equals 1. What do you guys, didn't we already get y equals 1 for something? Yeah. What was it? Horizontal asymptote. Your slant asymptote, if you have one, has to have an x in it. It's got to have a number in front of x. And then if you get just a horizontal line, your answer for slant asymptote is none. If you work out the long division and your answer is the same as the horizontal asymptote, then that means, oh wait, there isn't one. Because a horizontal line and a slanted line are not the same thing. There are specific cases on when you have slant asymptotes and when you don't. We'll talk about that in a second.
Can you go back to the
Sure. So which one?
So when the slant asymptote and the horizontal asymptote are equivalent, then it's none.
Mm-hmm. For the slant.
Right, for the slant, even if the horizontal asymptote is like 2.
Mm-hmm. Yeah, because what'll happen is when you work out the long division, when you work out the slant asymptote long division, you'll get y equals 2.
Right,
You'll
right.
get whatever the horizontal
Right,
asymptote is, yeah.
exactly.
All right, let's look at this next one. We're going to do the exact same thing. We're going to go through the whole gamut just to make sure we find everything. First thing we're going to find is domain and vertical asymptote. Where do I look for that? Denominator. So I have 3x squared minus 15x equals 0. Take out the 3x. I'm left with x minus 5. Agreed? Set each piece equal to 0. So I have x equals 0 and x equals 5. Those are your vertical asymptotes at x equals 0 and x equals 5. When you find the vertical asymptotes, what else are you finding? The domain. You're saying everything in the world will work except for those two numbers. So how do I write it? Negative infinity to 0. 0 to 5. Whoops. And 5 to infinity. Very good. Domain and vertical asymptotes go hand in hand. You're finding the same thing. All right, let's find our horizontal asymptote. Remind me again how to do that. Compare the degrees, the numerator and the denominator. What is the degree of the numerator? 2. What's the degree of the denominator? 2. What do you notice about those two numbers? They're the same. When the degrees of the numerator and denominator are the same, it's the leading coefficient. So what's the leading coefficient of the numerator? 1. What's the leading coefficient of the denominator?
3.
Your horizontal asymptote is at y equals 1/3. It's a fraction. That's okay. It's just between 0 and 1. No big deal. Let's go ahead to the slant asymptote. Slant asymptote is long division, yep? Okay, so on the outside is going to be 3x squared minus 15x. And on the inside is x squared minus 0x minus 4. First term into first term. 3x squared times what gives me x squared? Not 3, because 3 times 3 would be 9.
1/3.
It's 1/3. That's tough for you guys to visualize. Some last period said it can't. It doesn't. It not that it can't, but it's not something pretty. But if I go up here to 1/3, guys, do I have an x with my answer? No. So I'm going to multiply this out, and I'm going to get something crazy, whatever. But what this says is y equals 1/3.
This is the one.
What is y equals 1/3?
The horizontal.
It's the horizontal asymptote. So what is your answer for slant asymptote? None. Slant asymptote is none. Let's find x and y intercepts. How do you find those? How do you find the x-intercept? Numerator equal to 0. X squared minus 4 equals 0. X squared equals 4. Take the square root. So x equals what? Plus minus 2. Intercepts are written as ordered pairs. How do I write that? 2, 0, and negative 2, 0. Good. X-intercepts, y-intercepts, ordered pairs. How do I find y-intercept? 0 for what? All the x's. So I have 0 squared minus 4 over 3 times 0 squared minus 15 times 0. Yeah, okay. So 0 squared minus 4 is going to give me negative 4. What's going to happen on the bottom? What does it become? Guys, what's your y-intercept if the denominator is 0? Is there one?
No.
No. If your fraction is undefined, then that doesn't exist. There would be no y-intercept. If you had 0 over negative 4, what would your answer be?
0.
0. Do you guys see the difference in those two things?
Yeah.
When your denominator is 0, your fraction is undefined. That means there is none. There's no y-intercept. What do we need to find out? Wholes?
Yeah.
Okay, how do we find the wholes? What do we do for wholes? Factor. So we factor the top. It's x plus 2, x minus 2. We factor the bottom. 3x times x minus 5. Do you have anything on the top and bottom that is exactly the same?
No.
No. So what's your answer for wholes? There's no wholes. All right, what I want you guys to look at for slant asymptote and horizontal asymptote. On the two examples that we just did, there was no slant asymptote. Why? When we worked it out, what happened?
It was y equals
It was y equals what?
the number.
The number. It was y equals the horizontal asymptote. If you guys have a horizontal asymptote, you won't have a slant asymptote. If your horizontal asymptote is none, then yes, you will have a slant asymptote. The only time you'll have a slant asymptote, look, if I'm going to do long division, if the denominator degree is less than the numerator. So you see how my numerator is bigger? If I was going to divide this, x into x squared goes x amount of times. The only time you have a slant asymptote is when the numerator degree is bigger than the denominator. If it's the other two cases, you won't have one. So if you had a function, there was something like this on WebAssign. Say 4 over x squared plus 7. You're trying to find the horizontal asymptote. How do you find the horizontal asymptote again? You compare numerator and denominator degrees, right? Guys, what is the degree of the numerator? It's a constant, so this would be x to what power? To the 0. If you have just a number. So if you're going to compare, this would be 0 for the numerator and 2 for the denominator. So what is the comparison between 0 and 2? 0 is less than 2. If the numerator degree is less than the denominator, what's your horizontal asymptote? Y equals what? 0. So in this case, we have a horizontal asymptote. That means we don't have a what? A slant. Because watch, if you tried to divide this, x squared plus 0x plus 7 into 4. Or you want to say 4x to the 0. How many times, what would you multiply x squared by to get you x to the 0 power? It's not going to work. You can't do that. So that's why your slant asymptote here would be none.
So if you have one, you can't have the other.
Correct. Very true. If you have one of them, you can't have the other one. There's a couple different things you can look at your equation to figure out like which one, but if you just work it out. So what I want you guys to do now is pull up your quiz review and start working on it. You should have it done when you come in here tomorrow, or have a couple questions on I wasn't quite sure on this one or that one, and we can go over it. But that's going to be your review, and your quiz is going to be on Tuesday when you come in. Some people have already told me they're not going to be here Tuesday. The makeup will probably be on Thursday afternoon.